Good afternoon, my YouTube viewers. Crystal here. What I wanted to do is I wanted to make a video on something that I've been working on the last day. It's an analytics VidHire competition question. The competition question is in their ended submissions, and it's called Lord of the Machines. And what I'll do is I'm going to make a blog post on this. And when I make the blog post, I'll leave you the link to the code, and you can use the code if you want to. So the only way that you're going to get the code is to actually read my blog post. So I'm being naughty. But basically what I want to do is I want to go over this with you. And it was a little bit complicated because I had to think about how I was going to solve it. And then it's a multi-label class imbalance competition question. And then I solved the problem by creating two models. And I will show you how I created the models and why. But the first thing I wanted to do is I want to read you the problem statement. So let me see if I can get the problem statement up here. 1 second. Okay. So the problem statement is email marketing is still the most successful marketing channel and the essential element of any digital marketing strategy. Marketers spend a lot of time in writing that perfect email, laboring over each word, catchy layouts on multiple devices to get them best in industry open rates and click rates. How can I build my campaign to increase the click-through rates of email? A question that is often heard when marketers are creating their email marketing plans. Can we optimize our email marketing campaigns with data science? It's time to unlock the marketing potential and build some exceptional data science products for email marketing. Analytics VidHire sends out marketing emailers for various events, such as conferences, hackathons, etc. We have provided a sample of user email interaction data from July 2017 to December 2017. You are required to predict the click probability of links inside a mailer for email campaigns from January 18 to March 18. So it seems like it's a time series question in the beginning. And that's what it seems like. It seems like it's a time series question, but it's a classifier. And then it's a classifier because the answers are binary logic, either a 0 or a 1. So I thought about how I was going to go about solving this problem. And then when I thought about how I was going to go about solving the problem, I started writing the code for it. And I would like to say that writing code in 2020 is a lot different than writing code was 30 years ago in 1990. You can do a lot more with a lot less words. So that's one thing I was thinking about today. So the first thing we're going to do is we're going to import our libraries. So we're writing our code in the Python programming language, which is a very high-level programming language. So we imported the libraries pandas, SPD, NumPy, SMP, Matplotlib, PyPlot, SPLT, and Seaborn as SNS. So those were the libraries that we were most likely to use. So I just went ahead and imported them. And the next thing we did is we want to read our files, load our files. These files are so large that I cannot put them on my GitHub repository. So I had to store them in my Gmail account. So if you want the files, you're going to have to go to the Lord of the Machines. What's this competition question called? Lord of the Machines competition question, and download them from there because they were so big I couldn't put them on GitHub. Okay, so we read our train file. So you can see the train file has an ID, a user ID, a campaign ID, a send date, and then you got is open and is click. So the idea is that if it's an is open, it's if the is open is 0, the is click is going to automatically be 0. And then if the is open is 1, then it may or may not be 1. And so in theory, I could have, used a binarizer, but since the is open and in click and is click are actually missing from the test file, then I couldn't put a binarizer in there. So in the test file, I only got an ID, campaign ID, user ID, and send date. So that means I had to predict on the is open. That was the first prediction I had to make. And then the second prediction I had to make was on the is click. So what I had to do was I had to create 2 models, one model for is open and then a second model for is click. Or that's what I decided to do. I mean, other people may have decided to do other things, but they certainly haven't shared their work with me. And when I looked in the discussion page of this competition question, nobody offered to share their work. So I just had to guess, and this was my guess and my solution. So this is the sample. This is what Analytics Vidhya wants to see. They want to see the ID and the is click. So even though we've got 2 answers, one answer is open and the other answer is click, the only answer that they want to see is click. So we could have done it 2 ways. We could have done it as a multi-output classifier, which I might go back and do it as a multi-output classifier and see if my score improves. And then, so that's another thing I can try it as a multi-output classifier. But this one isn't a multi-output classifier. This is 2 different models. But I'll go back and do it as a multi-output classifier and see which algorithm works the best. So this is our data file, and this is the file that tells you all about the data. And I decided not to use the email body and not to use the URL. I just decided not to do that. Okay, so the next thing I did was I merged the data with the train file to make it one complete file, and I merged it on campaign ID so you can see I got all this new information in the train file. And then I did the same thing with the test file. And then what I did was I checked my null values for any null values. There were not any null values, so that was good. I didn't have to impute them. So now what we did was we checked train info just to see what kind of columns we had in there. And now we're doing a graphical representation of the data. So we've graphically represented the is open. So there's about 10% of the people opened the email. And then we did a graphical representation about is click, and about 1% of the people clicked on it. And then so what I did was I created a variable called link, so I could see all the total links. And so I graphically represented that so you can see all of the links that they had. So I did a graphical representation of link 1. So again, you can see that number of internal links. Now I created a variable called image. So you can see a graphical representation of the number of images. So I did a graphical representation of section. And now what I've done is I decided to convert the date to columns, but I've got like my own little file, but I didn't use all of them. I didn't use year because everything in the train file was 2017 and everything in the test file was 2018. So I didn't use that. And I didn't use second because they didn't have any seconds, they just had the minutes. And in addition to that, I converted these columns to integer columns because they were not, when they were converted over, they were objects, and I didn't want them to be objects. I wanted them to be integers. So they were converted to integers. So now we've got a new column with the day, month, hour, and minute in it, because I thought, well, that might make a difference. That might make a difference in whether they decide to open the email or not. So now what we've done is we've defined our first set of X, Y, and X test variables. So we did our ID equals test ID, and that was a variable we declared. Open train equals train is open, and click open is train is click. I developed features 1, and so features 1 is X1 and X1 test and Y1. So you can see all that. So now you can see Y1, you can see X1 test, and you can see X1 info, so you can see what kind of a data frame it is. Now what we've done is we have created our first column transformer. So we created our column transformer, and I decided to use the number of the columns for the column transformer instead of just the labels of the columns, because the numbers of the columns are quicker, and it's easier to identify and easier to change. So we had a numeric transformer with the numeric columns, and we had a categorical transformer with the categorical columns, and then we defined a preprocessor that has the numeric transformer and the categorical transformer in it. And now what we have is we split the X for training and validation, and so we split that up, and now we create our first pipeline. And then we decided to use logistic regression and set it up for balanced. And this is what I used. If you want to play around with it and see if you can get a better score, it's up to you. But I can't spend too much time on a program because then I have to make up a blog post on it. And then if I spend too much time on a program, then I can't write the blog post, and then I won't be paid. But I don't get paid much, believe me. It's enough. I get paid enough for a meal at McDonald's for me and my boyfriend. And hopefully this month, I'll get enough for maybe a meal at Taco Bell for me and my boyfriend. And then so we had like a 63.78% accuracy on that. we predicted on the validation set, and you can see that it did address the class imbalance. It probably addressed the class imbalance too well. And then so what we counted, how many were 0 and how many were 1. So you can see that it did actually address the class imbalance. And so we predicted on the test set, and I can't give you an accuracy of that, but I did actually put it on the SNS disk plot. And so you can see that it did work on the class imbalance, perhaps a little bit too well. Okay, and then we counted it. So we counted how many were 0 and how many were 1. So now what we've done is we've taken prediction, and we have created a column called is open and added that to the test file. So now we've got an extra column on the test file. So now what we're doing is we're doing our second model. So we're going to define x2, y2, and x2 test. So we've got features. Features 2 has everything that features 1 had, except it now has is open. So we create a column transformer. And so the column transformer is identical to the first column transformer we had, except for the fact that it includes the column that says is open in it. Now we've split our training set up. So that's exactly the same as the previous split, except for the X2 train, X2 and Y2 train have X2 train, X2 val have 11 columns instead of 10. Now we create our second pipeline. The second pipeline is identical to the first pipeline, except we're using X2 train, except we're using X2, Y2, X2 tests, and the first one we were using X1, Y1, and X1 test. And we had a 91% accuracy on that. We had much higher accuracy on that than we did in the previous one. So we predicted on the validation set, and we had a 91.35% accuracy. And so I plotted it, and you can see that the plot is a little bit better. It looks a little bit more like the original data of isClick. We counted it, and then we predicted on the X2 test. So I can't tell you what the accuracy is, but the only thing that I can do is show you a picture of it. But now that I think about it, because I had set this up for balanced, what I might do is I might go through and do it again and take the balanced out and see if my accuracy improves if I take the balanced out. That's a good idea. So we counted the zeros and ones, and then we made the sample file. And then we created our data frame to submit. And when I submitted it to Analytics VidHaya, I only got a 53.06 private score. And you may think, oh, well, that's not very good. But one, it was a lot of work. I had to think about what I was doing. And two, the highest score was only set 0.70682, so it was only 18 points less than the highest score. So it doesn't seem as bad as you would think it was. So that concludes this presentation.